Now this is the third lecture of morning session, and today we will continue the current electricity, because some questions, they may be definitely based on this chapter in your exam. Now here is one numerical given. The numerical you have to solve based on the formula of Ohm's law, then power. Yesterday we had studied the various formulas of power. P is equal to V square upon R, P is equal to VI, P is equal to W upon T, and we know the Ohm's law, V is equal to IR. Now read this problem. I am going to read that an electric iron uses 1100 watt when set to the higher temperature. एक इलेक्ट्रिक आयन है जो कपड़े को इस्त्री करने के लिए यूज करती है, उसकी पावर दी है. टू ट्राई टू राइट डाउन एंड फाइंड आउट द आंसर्स. दिस इज नॉट द प्रवचन दैट जस्ट यू हैव टू लिसन. हाई टेम्परेचर को अगर हम इस्त्री को सेट करते हैं तो वो 1100 पावर जो है एब्सॉर्ब करता है. इफ सेट टू द लोअर टेम्परेचर, क्योंकि टेम्परेचर सेटिंग होती है अभी जो मॉडर्न आयन से उसमें टेम्परेचर सेटिंग, लो टेम्परेचर को हम सेट करते हैं तो पावर ड्रॉ करती है 330 वैट. तो यहाँ पे P1 और P2 दो वैल्यूज मिली है हमें. फाइंड आउट द इलेक्ट्रिक करंट एंड रिस्पेक्टिव रेजिस्टेंस ऑफ द टू सेटिंग. तो पहली जो सेटिंग है जो हायर टेम्परेचर पे सेट करते हैं तो 1100 वैट पावर जब यूज होता है तो इलेक्ट्रिक करंट कितना उसमें से पास होता है ये फाइंड आउट करना है. और एट दैट टाइम व्हाट इज द रेजिस्टेंस ऑफ दैट आयन. एंड सेकंड थिंग वी हैव टू फाइंड आउट व्हेन वी यूज द आयन एट लो टेम्परेचर 330 watt, how much electric current it has been drawn and what will be the resistance of that electric coil. And potential difference applied in both the connection is same, 220 watt, because in India this is the potential difference available to us. First write down the given things. डोंट वेस्ट योर टाइम, थोड़ा स्पीड बढ़ाना है न्यूमेरिकल सॉल्व करने के लिए. P1, P2 330 watt, then V is 220 volt. You have to find out the I1, I2, then R1 and R2. We know that formula of power P is equal to which formula? VI. Therefore I is equal to P upon V. To find out the electric current, I1 is equal to P1 upon V. Then I2 is equal to P2 upon V. To find out the resistance, R1 is equal to R is equal to V is equal to IR. R is equal to V by I. Therefore V upon I1 and R2 is equal to V upon I2. Now all the formulas are in front of you. Given quantities are there. You just have to calculate and find out the answer. Quick. Yes. Carry on. पूरा problem solve करना है आपको. And you have to check your answer here. कहाँ पे गलती हुई है, क्या नहीं है.
B 330 W. A. Power is equal to 1100 W. I1 is equal to P upon V is equal to 1100 upon 220 is equal to 5A. B. Power is equal to 330 W. I2 is equal to P upon V is equal to 330 upon 220 is equal to 1.58. resistance R1 is equal to V upon I1 is equal to 220 upon 5 is equal to 44 ohm. Resistance R2 is equal to V upon I2 is equal to 20 upon 1.5 is equal to 146 ohm. Example 4. An electric tungsten bulb is connected into a home circuit. The home electric supply runs at 220 V potential difference. When switched on, a current of 0.45 A flows through the bulb. What must be the power wattage of the bulb? If it is kept on for 10 hours, how many units of electricity will be consumed?
Now see, there is a tungsten bulb जो फिलामेंट बल्ब से बना होता है. इलेक्ट्रिक होम सप्लाई रन्स ऑन 220 वैट पोटेंशियल डिफरेंस दिया है 220. स्विच ऑन अ करंट. अब जब इस पोटेंशियल डिफरेंस पे ये जो बल्ब चलता है तो इसके लिए करंट यूज होता है 0.45 एम्पियर. इट फ्लोज. व्हाट मस्ट बी द पावर ऑफ बल्ब? फर्स्ट यू हैव टू फाइंड आउट द पावर. क्या विच क्वांटिटी? पोटेंशियल डिफरेंस एंड कलर करंट. P इज इक्वल टू मिलेगा पावर. पावर तो मिल गई अपनी. अब ये जो बल्ब है हर दिन 10 घंटे के लिए चलता है. कितने घंटे के लिए चलता है? 10 घंटे. इफ दिस बल्ब इज यूज फॉर 10 आवर्स पर डे, तो एक दिन के लिए इसका इलेक्ट्रिसिटी बिल कितना आएगा यूनिट में? तो पावर तो आपको फाइंड है. 1 यूनिट इज इक्वल टू 1 किलोवाट आवर. 1 यूनिट इज इक्वल टू 1 किलोवाट आवर. तो यहां पे गिवन पावर तो हमें फाइंड आउट करनी है. I इज गिवन 0.45 एम्पियर. V is 220 watt. You have to find out power by using the formula P is equal to VI, and number of unit is equal to kilowatt hour. Kilowatt into hour. The power which we get, it is in watt. Power which we get by using this formula, it is in watt, because this we are solving this problem by using SI unit. Then the power you get in the watt, convert it into kilowatt. Convert it into kilowatt. And we have given the time in hour, that is 10 hour. तो watt में जो पावर मिलती है उसको किलोवाट में कन्वर्ट करना है, फिर पावर से मल्टीप्लाई. यूनिट्स फाइंड आउट द यूनिट्स. Yes, to convert the watt into kilowatt, we have to divide it by 1000. 1000 divide करो 0.099. अब 0.099 दिस इज द किलोवाट. उसे मल्टीप्लाई करो 10 से. You will get the answer 0.99 units. How much unit? If this bulb, आपका आंसर आ गया 0.9. If this bulb is used in the month of May, we are using this bulb in the month of May, and the rating for the unit is ₹5 per unit. Then tell me what is the bill for that bulb in that month. उस बल्ब का एक महीने का, मई महीने का बिल कितना होगा? एक यूनिट के लिए 5 रुपए. एक दिन का कितना यूनिट है? 0.19 है. मई महीने में कितने दिन होते हैं? 31. तो 31 मल्टीप्लाइड बाय 0.19 है. ये हो गए आपके यूनिट्स. एक यूनिट के लिए कितने रुपए आए? 5 रुपीज. तो एक महीने के लिए कितना आएगा? मल्टीप्लाइड बाय 10. समझ में आया? हाँ, 153 रुपए.
Given potential difference is equal to 220V, current is equal to 0.458, power W is equal to potential difference
If it is
V
used
into
for 1
current
month,
A
that is
is
May
equal to
31 multiplied by 0.99. Whatever is your answer, you have to multiply it
The
by
bulb must be of power
Five.
99 watts.
this is your final
In
answer.
10 hours, 99 watts into 10 hours is equal to 990 Wh. That is equal to 0.99 kWh. Magnetic effect of electric current.
Chalo, next.
We have learned about heating effect of electric current.
Now we have to study the magnetic effect of electric current. We know the heating effect of electric current. Heating effect पता है हमें. When electric current, when the electric current flows through the wire due to the resistance, heat energy is produced because obstacle is there for the flow of electrons, and due to the obstacle kinetic energy decreases, and due to the collision that kinetic energy converts into the heat energy, that we call as heating effect. Now we have to study the magnetic effect. We know that when electric current goes through the conductor, then what happens? Magnetic field is produced around the conductor. Magnetic field is produced around the conductor, and this is called as magnetic effect of electric current. The magnetic field produced around the conductor, it is similar to that of the magnetic field around the bar magnets. But there is some difference between the magnetic field produced around the bar magnet and the magnetic field which is produced around the electric current. What is the main difference between this electric field between the bar magnet and वायर के ऊपर जो इलेक्ट्रिक मैग्नेटिक फील्ड प्रोड्यूस होती है उस फील्ड में, और बैक मैग्नेट के ऊपर जो मैग्नेटिक फील्ड होती है, इन दोनों के मैग्नेटिक फील्ड में क्या फर्क है? हाँ, वी कैन चेंज द डायरेक्शन ऑफ मैग्नेटिक फील्ड which is produced around the conductor, because by changing the direction of electric current, direction of magnetic field changes. Again, bar magnet is temporary. Magnetic field produced around the bar magnet is permanent, and this is temporary. As soon as the current flows, it produces the field, and if it stops the current flowing through it, the magnetic field vanishes. Again, difference. We can increase the strength of magnetic field. We can increase the strength of magnetic field. How will you increase the strength of magnetic field? By increasing the flow of current. And again, if we wrap the wire in a shape of coil, by increasing the number of turns of coil, we can increase the magnetic field. That is called as solenoid. That all the things we have to study. Then who discovered the relationship between magnetic field and electric current? Hans Christian Oersted. What is the unit of magnetic field? Magnetic field किसमें measure की जाती है? Right answer. Who gives the answer? Very right. Who gives the answer? Right. Yes. जोर से बताओ. Tesla is the unit of magnetic field. It can be measured as Newton second per coulomb. Newton second per coulomb. Okay. And its symbol of magnetic field is B or H, capital. Note down this point, units and its
Correct.
symbol.
In previous standards, we have studied about magnets and magnetic
These lines are called as, what we call these lines? Magnetic field lines. What is the another name? Magnetic line of forces. Do you know the properties? Properties repeat करने की जरूरत है? Very good. And what is the direction of magnetic field?
lines of force.
Not
However,
to
it
south.
will be interesting to see if an electric current and magnetic field are related to each other. Try this. Connect the circuits as shown in figure. Connect a copper wire, thicker and straight as compared to the connecting wires between A and B. Keep a magnetic needle adjacent to the wire. Keep the plug key open in the circuit and observe the direction of the needle. Close the plug key and observe the direction of the needle. What do you notice? Now,
What happens here? By changing the direction of electric current, the depletion of magnetic needle also changes. The direction of depletion of magnetic needle also changes. It means that there is the relationship between the electric current and magnetism. ये तो पता है हमें, इलेक्ट्रिक करंट की वजह से मैग्नेटिक फील्ड वहां प्रोड्यूस होती है and it is detected by magnetic needle.
interchange the connecting wires connected to the cell and observe the direction of the magnetic needle. Do you notice any relation between the direction of current and position of the needle? What do you learn from this experiment? The magnetic effect is observed because of the current in the wire. This means electricity and magnetism are closely related. On the contrary, if a magnet is moved and kept moving, will we observe any electric effect? Is it not exciting? Therefore, we are going to study magnetic fields and such electromagnetic effects. Finally, we will study the principles, construction, and working of electric motor and electric generator. Introduction of scientist. When a large current, approximately 1 A or more, flows through the thick copper wire passing through a cardboard, the magnetic needle kept at different points on the cardboard around the wire stands in different directions.
तो क्या एक्सपेरिमेंट है, यहाँ पे आपको दिख रहा है कंडक्टिंग वायर है, इस कंडक्टिंग वायर को किया है कार्डबोर्ड में से पास किया. दिस इज द स्ट्रेट करंट कैरिंग कंडक्टर. इसे क्या कहेंगे हम? स्ट्रेट करंट कैरिंग कंडक्टर. when we keep the magnetic needle near to the various points of the conducting wire, you can see the depletion in the magnetic current. According to the right hand thumb rule, thumb should be in the direction of electric current. Then curved fingers gives the direction of magnetic field. Then tell me, what is the direction of magnetic field? Anti-clockwise. If the current flows in downward direction, clockwise. If the current flows to this direction, anti-clockwise. If current flows to this direction, clockwise. इस तरह से हम मैग्नेटिक फील्ड की डायरेक्शन फाइंड आउट कर सकते हैं. फ्लेमिंग्स राइट हैंड थंब रूल. अब इसके बाद दो रूल है, लेफ्ट हैंड रूल, राइट हैंड रूल. तीन रूल, फ्लेमिंग्स राइट हैंड थंब रूल, लेफ्ट हैंड रूल फॉर इलेक्ट्रिक motor and right hand rule for electric generator.
Mark these directions with a pencil. Discuss with your friends and teachers about the requirement of the current, number of cells, cells of what potential difference, thickness of the wire, etc., and then perform the experiment. The direction of the current shown in the circuit is its conventional direction. What changes are caused by increasing or decreasing current? What do you see when the magnetic needle is kept a little away from the wire? Now, instead of the magnetic needle, spread iron filings on the cardboard and observe. The iron filings arrange themselves in a circular manner around the wire. Why does this happen? You have studied magnetism and magnetic field in previous standard. The iron filings spread along the magnetic lines of force.
Magnetic line of forces are formed around the straight current carrying conductor. और ये जो लाइन्स जो है, लाइन्स हमें क्या दर्शाती है? Magnetic field, the strength of magnetic field. And these lines are more crowded near the wire and it becomes bigger, circle becomes bigger and bigger if we move away from the wire. It means that magnetic field goes on decreasing if we move away from the wire. Keep in mind the properties of magnetic field lines. Magnetic field lines never intersect with each other. They always runs from north to south poles. Okay. Magnetic field lines are more crowded near the poles. Therefore, the magnetic field or the strength of magnet is effective, or magnet is effective near its pole. मैग्नेटिक फील्ड जो इसकी स्ट्रेंथ पोल्स के पास ज्यादा होती है.
Always remember, a magnetic field is produced around a straight current carrying conductor. If the current is unchanged, this magnetic field reduces as the distance from the wire increases. Therefore, the concentric circles representing the magnetic lines of force are shown bigger and rarefied as the distance from the wire increases. If the current through the wire is increased, the intensity of the magnetic field increases. Right hand thumb rule. This is a convenient rule for finding out the direction of the magnetic field produced by a current flowing through an electrical conductor. Imagine that you have held the conductor in your right hand in such a way that your thumb points in the direction of the current. Then turn your fingers around the conductor. The direction of the fingers is the direction of the magnetic lines of force. Find out. The right hand thumb rule is called Maxwell's corkscrew rule.
हाँ, इसको भी याद रखना.
What is the
Maxwell's corkscrew rules, राइट हैंड थंब रूल को कहते हैं, क्योंकि मैक्सवेल ने स्क्रू फाइंड आउट किया था. स्क्रू तो पता है ना सबको. तो इस स्क्रू में जो लाइनिंग्स जो जाती है, तो उसी तरह से मैग्नेटिक फील्ड लाइंस हम इसको पता कर सकते हैं. क्योंकि स्क्रू को अगर हमें कोई स्क्रू फिट करना है तो कौन से डायरेक्शन में फिट करते हैं? क्लॉकवाइज या एंटी क्लॉकवाइज? क्लॉकवाइज. और ओपन करना है तो एंटी क्लॉकवाइज. तो इसी तरह से मैग्नेटिक फील्ड लाइन की डायरेक्शन इस स्क्रू के साथ क्या होती है? मैच होती है. इसीलिए मैक्सवेल्स कॉर्कस्क्रू रूल भी इसे कहते हैं.
The corkscrew rule. Magnetic field produced by current through a circular loop of a conducting wire.
हाँ, अभी तक हमने क्या पढ़ा है? मैग्नेटिक फील्ड प्रोड्यूस अराउंड द स्ट्रेट करंट कैरिंग कंडक्टर. अब इसी कंडक्टर को अगर हम लूप के फॉर्म में करेंगे, इसका सर्कल बनाते हैं, तो सर्कल बनाते हैं तो इसमें क्या होता है? जब हम कोई भी वायर जो है इसे सर्कल फॉर्म में suppose this one is the wire, we made a circle of this wire and if it is connected to the circuit, okay, circuit में इसमें उसको कनेक्ट किया, तो we know that magnetic field is produced at every point on the circle. सर्कल में हर एक पॉइंट पे मैग्नेटिक फील्ड तैयार हो रही है, बरोबर. It means that the magnetic field lines produced here like this, here also and here also. It means that large number of points are there on the circular loop and the magnetic field produced by the each point get add up in the center of circle, and in the center of circle the arc of the circle, it appears to be a straight line. It means that the strong magnetic field is produced in the center of circle because the magnetic field produced by the each point get add in the center of the loop. अब ये तो एक ही लूप है, एक लूप के सेंटर में स्ट्रॉन्ग मैग्नेटिक फील्ड तैयार हो. If we increase the number of circle, number of turns, n number of turns, if there are the n number of turns, then n times the magnetic field is produced by the loop. तो लूप जब हम तैयार करते हैं तो उसमें हमें स्ट्रॉन्ग मैग्नेटिक फील्ड प्रोड्यूस होती है. You can apply the right hand thumb rule at every point, then you can get the direction of magnetic field की direction. But if we find the direction, you can see that the direction of magnetic field lines are same at every point. हर एक पॉइंट पे मैग्नेटिक फील्ड की डायरेक्शन क्या होगी? सेम. इट इज फ्रॉम नॉर्थ टू साउथ, एंड दिस इज द इंपॉर्टेंस ऑफ मैग्नेटिक फील्ड प्रोड्यूस्ड बाय द सर्कुलर लूप.
We learned about the magnetic lines of force of a magnetic field produced by a current flowing through a straight conductor. What will happen to the magnetic lines of force of the field produced by a current flowing through a loop made by bending the straight wire? A circuit is completed by connecting various.
अब यहाँ पे क्या किया है? ये जो है कार्डबोर्ड है और कार्डबोर्ड से एक वायर को पास किया है, उसको दो छेद गिरा के इस तरह से कि ये क्या तैयार कर सकता है? सर्कुलर लूप. अब कार्डबोर्ड से क्यों पास किया है? क्योंकि उसके ऊपर हम आयन फिलिंग को स्प्रिंकल कर सकते हैं और आयन फिलिंग स्प्रिंकल करने के बाद जब करंट पास होगा तो आयन फिलिंग्स फॉर्म्स द कॉन्सेंट्रिक सर्कल ऑन द नियर द वायर, जहां से वायर आए यहाँ पे कॉन्सेंट्रिक सर्कल तैयार होगा. देन यू कैन सी हाउ द मैग्नेटिक फील्ड इज प्रोड्यूस. ये प्रैक्टिकल है, प्रैक्टिकली हम फाइंड आउट कर सकते हैं हाउ द मैग्नेटिक फील्ड इज प्रोड्यूस अराउंड द सर्कुलर लूप.
Various components as shown in the figure. If the current passes through the loop, magnetic lines of force are produced at each point on the loop. As we go away from the wire, the concentric circles representing the magnetic lines of force will become bigger and bigger.
अब देखो यहाँ पे हर एक पॉइंट पे, यहाँ पे दो ही पॉइंट लिए, दो पॉइंट पे मैग्नेटिक फील्ड प्रोड्यूस हो रही है, और जैसे जैसे हम सेंटर में जाते हैं तो हर एक पॉइंट की मैग्नेटिक फील्ड जो है यहाँ सेंटर में ऐड होगी. एंड सेंटर में जो आर्क जो है इट इज द स्ट्रेट लाइन.
As we go towards the center of the loop, the circle becomes so big that its arc can be shown as a straight line.
ये क्वेश्चन आता है कभी कभी, क्या इन द सेंटर ऑफ द लूप द आर्क ऑफ द सर्कल अपीयर्स टू बी a straight line, और स्ट्रेट. इसका रीजन क्या देंगे आप? What is the reason behind it? You know the reason? Because strong magnetic field is produced in the center of loop. The magnetic field produced by each point get added. यही simple reason है इसका. अस्मिता बोरेगा, shut up. Go out of the class. Wash your mouth and then enter the class. Get out.
In figure, the magnetic lines of force are shown near the points P and Q only. However, they will be created near each point on the loop. Likewise, each point will produce magnetic field at the center of the loop. By making use of the right-hand thumb rule, check that every point on the loop contributes the magnetic lines of force at the center of the loop, and these lines of force at the center of the loop are in the same direction. The intensity of magnetic field at any point produced by current flowing through a wire is dependent on the current, as we have seen in the experiment. Try this. This means that if there are n turns in the loop, the magnetic field n times of that produced by a single loop will be created. On discussing with your teachers with their guidance, see if you can perform the above experiment by collecting appropriate materials. The direction of the magnetic field can be determined with the help of a magnetic needle. Magnetic field due to a current in a solenoid. When a copper wire with a
ये लास्ट पॉइंट ये डिस्कस करेंगे, इसके बाद हिस्ट्री का पीरियड स्टार्ट होगा. दिस इज कॉल्ड एज सोलेनॉइड. इस तरह की कॉइलिंग आपने बहुत जगह पे देखी होगी, हीटर में भी होती है, बहुत सारे इलेक्ट्रिक इक्विपमेंट में भी होती है. तो इट प्रोड्यूसेस द स्ट्रॉन्ग मैग्नेटिक फील्ड बाय यूजिंग द n नंबर ऑफ टर्न. तो ये तो सब यहाँ पे दिया हुआ है. वी विल डिस्कस द डिफरेंस बिटवीन द सोलेनाइड एंड मैग्नेट. मैग्नेट और सोलेनाइड में क्या फर्क है? द मैग्नेट इज सॉलिड एंड सोलेनाइड इज hollow. What is the solenoid? If the insulated copper wire is wrapped in a shape of cylinder, then it is called as solenoid. Okay. Solenoid is hollow, magnet is solid. Then again, we can produce the stronger magnetic field by increasing the n number of turns. And this is the electromagnet. Solenoid behaves as a electromagnet. और क्या फर्क है? The uniform magnetic field is produced inside the solenoid. And this, what is the use of solenoid? Solenoid is used to make the permanent magnet. If the piece of iron is kept inside the solenoid, then it converts into the permanent magnet. ये याद रखना है.
The resistive coating is wound in a chain of loops like a spring. It is called solenoid. Whenever an electric current passes through a solenoid, magnetic lines of force are produced in a pattern as shown in figure. You are aware of the magnetic lines of force of a bar magnet. The properties of the magnetic field of a solenoid are very similar to the magnetic field produced by a bar magnet. One of the open ends of a solenoid acts as a magnetic north pole and the other as a magnetic south pole. The magnetic lines of force inside the solenoid are parallel to each other. What does this mean? This means that the intensity of the magnetic field within the solenoid is uniform everywhere. That is, the magnetic field in a solenoid is uniform. Force acting on current carrying conductor in a magnetic field.
This we will study later on. The force acting on current carrying conductor when it is kept in a magnetic field, and this is the basic principle behind the electric generator. Electric generator का ये principle है. When we kept the current carrying conductor in a magnetic field, the force is act on it, and due to the force, the coil rotates. Due to the force, coil rotates. We get the kinetic energy, and this kinetic energy is used to run the various appliances. जहाँ पे भी कोई भी electric appliance पे जहाँ पे motion होती है, they contain the electric motor in it. Okay. इसमें अभी इलेक्ट्रिक मोटर ये प्रिंसिपल पढ़ने के बाद हमें इलेक्ट्रिक मोटर पढ़ना है, फेरेनाइट्स की कुछ प्रिंसिपल है, और उसके बाद इलेक्ट्रिक जनरेटर एंड न्यूमेरिकल्स.